So now let's take a look at why we are even interested in zero modified or zero inflated distributions. So let's consider an insurance company who sells bike insurances. So here we have an insurance company who sells bike insurance. And they do so with a certain amount of deductible. Let's just say that the deductible is equal to 1,000 kroners. So if you encounter some kind of accident or incident with your bike and the damage is below 1,000 kroners, then you pay for the loss yourself. However, if the damage is above 1,000 kroners, you pay 1,000 yourself and the company pays the rest. So let's just take a look at how we would count, how we would model bike accidents. So if we let M denote the number of bike accidents per person, and with accidents, I mean accidents or incidents. So stolen bike, crashed bike, damaged bike, rusty bike, whatever. Then normally, well, this number will be 0, 1, 2. If you're really unlucky, maybe even 3, and if you're really, really, really unlucky, maybe even 4. So something like that. And this will be the number of bike accidents per person, and then it will probably follow some type of distribution, right? So normally we tend to assume that the higher the number of accidents, the less people have had so many accidents. So this is the number of people who have had 0 accidents, so number of customers with M accidents. So the number of people with 0 accidents are here, the number of people with 1 accident, 2 accidents, 3 accidents, 4 accidents. However, something that we kind of need to remember is some of these accidents result in damages below 1,000, in which case the insurance company never hears about them. And some of these accidents result in damages above 1,000, in which case the insurance company hears about them. So among these people who encounter 1 bike accident each, a number of these accidents might never be given to the insurance company. So the insurance company might only hear about this part, and the same for people who encounter 2 accidents and 3 accidents and so on. Which means that if we were really to consider the number of claims that an insurance company sees in their own data, so if instead of writing up the number of bike accidents, I write up N as the number of claims paid out for each person, so claims per person, and by this I mean, there is only a claim report if the damage is above 1,000, right? So what happens here is, even if there are some people who have encountered many accidents, if there are small accidents, then they will never be reported to the insurance company, which means that a certain number of these accidents, so if this is the number of people with no accidents, then there is also this up here, which is the number of people who do encounter accidents, but do not encounter big enough accidents. And then, of course, we have the rest down here. So what's the difference between the distribution of M compared to the distribution of N? So what's the difference between the distribution of bike accidents per person versus the distribution of claims per person? Well, the thing is, the distribution of claims per person will have a much higher number of zeros, right? It will have a higher probability of encountering 0 just based on the fact that apart from not having an accident, the number 0 also signifies that if n is equal to 0, then maybe this person did have an accident, but the damage was just not high enough to meet the deductible of 1,000 kroners. So that also means that whenever we look at any population of people inside an insurance company, there could be an overrepresentation of zeros. And in order to model this, what we do when we model the number of claims is not to model the so-called M, which is the number of bike accidents, which we might have a certain distribution for, probably the Poisson distribution. What we do is we model a so-called zero-inflated version of M, and we call it zero-inflated because we take the number of zeros for the accidents, for the people with zero accidents, and then we inflate it with the number of people who did have an accident, but no claim because the accident was not serious enough. So how do we model this? How do we do this? Well, we say, well, yes, M can be 0 or 1 or 2 or 3, but apart from that, we also assume that there is a probability 1 minus P that the damage will never be big enough to be reported. So 1 minus P is actually the probability that an accident is not serious enough or does not exceed the deductible. So an accident is not serious enough to be reported. And that is the reason why we look at zero-inflated distributions, because they are actually the distributions that are better suited for modeling the number of claims. Often, in many cases. Depends on who you ask, really. It's also subjective. Just forget I said it was better suited. Depends on who you ask. Well, anyways, the thing is, in C, we're asked to show that for the zero-inflated version of M, so for N, we're asked to show that the variance exceeds the mean, so that we're asked to show that there is a greater variance than in the case of the Poisson distribution, where the variance is equal to the mean. Now, how can we see that intuitively? Well, this is the distribution of M, this is the distribution of N, the claims. What we see is that there's a smaller number of values up here, and there is a greater number of values over here for the zero. So we kind of take something and then we move it away. We move it further away. We take stuff from up here and then we move it all the way down to 0. So in a way, what we do here is actually that we're increasing the variance. And also, we're actually making the mean smaller because we're taking higher values and turning them into 0, because the people with claims up here, probably some of them did not have claims that were above 1,000, so we move them down to 0. So what we do when we do this kind of zero inflation is that we stretch out the distance between certain values, and also we decrease the mean. So that is the intuition behind C. So that was that, zero inflation. Pretty interesting subject, and also pretty interesting in relation to mixtures and thinning, which you will read and learn more about in next week. So in the next video, we will do the solution of these A, B, and C in 4-9, and cheers!